Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and in this video I'm going to be explaining a little bit more about the previous video where I talked about the mean value theorem and its various different forms, and I'm going to show you using an applet what all those things mean. So let's begin. Now, this is the article that I showed you, and I'll place a link to it again once in the details section. So what I've done here is I've taken two curves, two functions. F of x is the primitive, and f prime of x is the derivative, right? They're both functions. And I've selected a region here between these two ordinates, okay? And let's see what all the different forms are. So the first form, this mean value theorem that you see in red up here, is that there exists at least one f prime of c. In other words, in this case here there are two, because now there is one if I move this, if I change this distance, but there are two because the area under the curve has place for both of these level terms. Okay, so there's a level term here, this level y ordinate here, and a level y ordinate here. So, and if I do this, now there's only one level y ordinate, and obviously if I go to both sides like that, then there are two, and in some functions there may be even more, but there's always at least one. So f prime of c, this ordinate here, is in the vernacular, the arithmetic mean of all the y ordinates, of all the y f prime of. In other words, what it's telling you is that all these ordinates under the red curve, okay, and between the x-axis and between the green lines, have an arithmetic mean, or a better is a level term, which are these pink lines or magenta lines, whatever. Okay, so that's what the mean value theorem is telling you, that there exists a c such that there is a tangent parallel to a secant line is unremarkable. It's a property of all smooth functions. Right, so that's the MBT, and of course if we move this anywhere, we'll see that we can find the area using the MBT, right? Why? Because we can take any level term like the magenta one and simply multiply it by the interval width. And so what we end up having is, right, we have the area of this rectangle, the area under this green rectangle. Okay, so I'm not drawing it properly because I'm using my mouse, but you know what I mean, right? That area. Okay, so and of course the fundamental theorem is derived directly from the mean value theorem. It's simply the level term multiplied by the interval width. Okay, so it's the level term multiplied by the interval width, and that is the fundamental theorem of calculus. And so from that, then, we have the average, the hilarious average value theorem, which is the same thing again, because all we're doing is we're taking this expression here and dividing it by the interval width b minus a. In other words, we're obviously going to get back to f prime of c when we do that to the f doc, aren't we? So again, it's the same form. And the last one is also very hilarious because it's called the mean value theorem for integrals. And in fact, the mean value theorem for integrals are described over here. Okay, that's basically the mean value theorem, and of course this integral is this particular expression on the left hand side of the f doc. So my friends, that's pretty much it. So you've got four different theorems in the mainstream. It just goes to show you how little the arrogant and ignorant academics of the last few hundred years understood about calculus, because all these theorems are really the same. So the fact that you can replace this with f doesn't change the theorem. It's true because f prime of x is also a function, by the way. In terms of being a smooth function, there's really no difference between f prime of x or putting an f here. So if you want to express the so-called hilarious mean value theorem for integrals, you can also express it like that. That's fine. Remember that f of x and f of x are functions, right? So, but stupid academics have never understood these things. So that's pretty much it. If you're not already a subscriber, become a subscriber. I'll place a link also to the applet, which you can download. Unfortunately, you have to send me a share request because Google doesn't allow one to access the folders unless they are granted access. But I'll grant you access to the whole folder if you want. So you just have to let me know when you ask to share or download the applet. But let me tell you this, the article is free here on academia.edu. So I'll also place a link to that in the details section. Now, if you haven't already subscribed, please subscribe to my channel and tell your friends about it. And you can also contribute dollars or credits to my Odyssey channel, which I'll also place a link. And that's pretty much all I have to say. I hope you've enjoyed this video, and if you have any questions, place them in the details section. By the way, I don't want the attitude, so if you're going to give me attitude, I'm going to delete your comment. I am I am the smartest guy as far as mathematics goes on the planet. Nobody understands calculus as well as I do. So ask a question rather than voice your ignorance and remove all doubt that you're a fool. So I'll explain everything if you ask in the right attitude. And only one question at a time, please. Also, do not write a long rant because my eyesight is not very good and I do not read long rants. That's pretty much it. I'm John Garyville. This is New Calculus Channel. Till next time, goodbye.